Good morning. Today I'm going to switch a little bit from the previous videos from the philosophical point that Alex Epstein has shown us to start with a little bit of simple science just to show you a percentage of what we're dealing with here in the issue of CO2. Now, we have this group of greenhouse gases in our atmosphere, and our total atmosphere is full of lots of stuff. So how big is the part of CO2 in this whole picture? And that's what we're going to look at today. The first picture we're going to look at today is a simple little graph to show you a percent of CO2 in the atmosphere. The first square up on top here is the Earth's atmosphere. Our Earth's atmosphere is made up of nitrogen, oxygen, and then we'll get into the everything else here in just a second. As you can see up there, the red is the oxygen. We're around 20-some% in the oxygen area. Buku's a nitrogen. And then everything else, all the little global warming gases, are down here in those little green squares in the bottom left-hand corner. Now, if you take that bottom left-hand corner and now blow those little squares up into a one square graph, you're going to see the greenhouse gases. These gases comprise of carbon dioxide, argon, noble gases, water vapor, which is the biggest warming gas we have. And as you can see from this chart, on the bottom there we have the water vapor in the nice pretty blue for water. Then we have argon and noble gases in the green. And then you'll look up there and you'll see that one little pixel of the carbon dioxide. Now remember, of this whole atmosphere up here, this is the bottom left corner blown up, and that's how big the carbon dioxide is in that little corner. Now, if we just take the carbon dioxide square and blow it up to see how much man-made CO2 is being produced and put into the oxygen, we can see those four little squares in the bottom left-hand corner out of the whole box of CO2. So this is meant to give you a perspective on how much CO2 is in our atmosphere, which is about 0.04%. It's minuscule. So being so small, then it must have an extremely large heat factor, right? Well, CO2 absorbs just a certain range of infrared heat. Okay, heat is light, infrared is light, and that's, different wavelengths for different heats. So carbon dioxide is good at absorbing a certain wavelength. Now our next video here will show you the rate at which carbon dioxide absorbs heat. Now, if this were a linear, use my tongue, in other words, a straight line, it might be concerning. In other words, if that blue line started down there at the bottom and then continued at an angle straight up and just continued as a straight line going up, that would show that definitely the more CO2 into the atmosphere, the more warming effect it's definitely going to have. But what we see here is not a linear line, but a curved line. As you can see, as you start to put CO2 in the atmosphere, it starts to absorb more and more heat. Okay? But as we start getting more and more CO2 in the atmosphere, there's less of that wavelength to be absorbed. So CO2 can only absorb the one one wavelength, and when we get to a point of about 300 parts per million, you can see this line has already started to flatten out. At 400, it's a small increase. At 550 parts per million, we're still getting a very minimal increase in warming from CO2. And this will continue to flatten out with more and more CO2 you put in the atmosphere. So the CO2 itself is not going to produce a great amount of warming when you consider the percentage of the previous graph, where we see how minuscule the amount of carbon dioxide is in the atmosphere, and the warming effect that it can have on the earth. We're going to see that CO2 is very difficult for it to have much of a warming of the earth's temperatures by itself. Now this will take you to the next part of the equation. We'll get a little deeper into this. This is where your models start to do all the forcing, because this is where your climate change gets really, really complicated, because it's so much more than just the sun shining and the CO2 trapping heat. You have positive forcing factors, you have negative forcing factors. And the global model scientists have to try and calculate precisely how all these factors play in. Well, some factors might be kind of constant, and you can figure the correlation between them. But a lot of factors in the earth are unpredictable. One good example is cloud cover. Cloud cover makes an enormous difference in how much heat is trapped or let loose. But there's no way you can model cloud production. Yeah, that at best is going to be a guess at how many clouds we're going to have. Yeah, we can look at the past experience and interpolate that into a future possibility. But unless you know exactly how clouds are made and how many clouds that the earth is going to make, you're going to run into issues. So this is where a lot of the problems come in with the climate models, is the quote, quote, forcing agents, the pluses and the minuses. How great are they? How minimal are they? That's why it's really, just like a lot of science, is just trying to be an educated guess. Now, I have read a lot of climatologists, physicists, meteorologists that all have serious issues with the forcing agents that the climate modelers put into their global warming models. This is why we do have to bring ourselves into the discussion. Even though we're not scientists, we have to listen to what the scientists are saying, and we have to make reasonable judgments. Now, when scientists get into name calling and just dismissing another scientist as a quack, let's remember they all put these things out to advantage their viewpoint. Yes, even the skeptics probably tweak their numbers to make, and graphs especially. Graphs are terrible. Graphs will eat you up, because graphs, a lot will depend on how you draw the graph. Your numbers may be good, but just simply changing the size of a graph can make a difference in how it looks. And your scientists for the positive side of they're definitely sure it's going to warm. I guarantee you their numbers and figures are tweaked to their advantage. So on most of these claims, most of these charts, I would suggest you kind of take an average between the two, and that's probably going to get you pretty close to a safe bet in what you're going to assume climate warming or climate change is going to do. If you have any questions, please let me know. I'll try and clear them up. Have a good day.